Good day and Assalamualaikum. I'm Siti Nojian binti Johari. Together with my teammate DJC, we will be presenting our mini project about fingerprint recognition system. And I will start the presentation by presenting the problem background of this project. So as we all know, in many security systems today, accurate and efficient user authentication is very critical. Traditional methods like PIN and password are not only vulnerable to theft, but the user can also easily forget them. So fingerprint recognition offers a more reliable and secure alternative because this system relies on accurately extracting key features called minutiae, specifically range endings and bifurcation from fingerprint images. But this process isn't always straightforward because the raw fingerprint images often contain noise, low contrast and broken ridges that could reduce the system overall recognition accuracy. So to overcome these challenges, a structured image processing pipeline is essential. These typically involve a series of steps, which are enhancement, filtering, binarization, and thinning that will help clean and prepare the image before the minutiae extraction stage. And the objectives of our project are to enhance fingerprint image using a structured processing pipeline, to extract accurate minutiae points like ridge, endings, and bifurcations, and to validate the result using sample fingerprint data. And this is the methodology of our system. So first of all, the fingerprint image is loaded. If it is in the RGB format, we will convert it to the grayscale because that is what needed for processing. And next, we will apply the histogram equalization to improve the contrast to make sure the ridges more visible. Then we use the median filtering with 3x3 window to remove the salt and paper noise while keeping the ridge edges sharp. And then the clean image will be binarized using the adaptive thresholding with a sensitivity of 0.4. And then we enhance the binary image by closing gaps using morphological operation, bridging broken ridges, and removing the tiny noises element using 30 pixels. And then we thin the ridges down to a single pixel width using morphological thinning. And then minutiae points, which are the ridge endings and bifurcations, are extracted using a 3x3 neighborhood check and visualized with the green and red markers. And finally, we match the minutiae between two fingerprints by checking if corresponding points are within 15 pixels. And then a match score above 0.8 confirms a match. All processing steps, extracted minutiae and match result are displayed at the end. Next, this is the program code of our system. This is the code for processing the image. And then this code is to extract ridge endings and bifurcation, extract the minutiae. And then this code is to display the pipeline. And then this code is to compare ridge endings and bifurcation from the two fingerprints. And then this is to display the match result. And this is our main function, which is for the GUI of our system. Then I continue the presentation with the output of our system. So basically this figure shows the UI of our system with both input images, processing buttons, and the final matching result. And this interface also allows user to load fingerprints, perform matching, and view the result. And then this output is to show the processing of both fingerprints step by step, like I've mentioned earlier in the methodology. And the last one, this figure shows the miniature-based comparison of the two fingerprints. Ridge endings and bifurcations are marked in green and red. Despite small differences, the pattern aligns well, resulting in a similarity score of 0.83. Since the score is above the threshold of 0.8, then the system identified that the fingerprint has a match, as shown in the GUI. And last but not least, to wrap things up, we successfully developed a fingerprint recognition system that preprocesses RGB images through a structured pipeline, including contrast enhancement, noise reduction, binarization, morphological processing, and thinning. We extracted the ridge endings and bifurcations from the thin image and used a distance-based method for matching. and a matching threshold was applied to determine whether the two fingerprints are matched or not, then the result showed that accurate fingerprint recognition depends heavily on effective pre-processing and precise minutia extraction. And the last one, these are the references that we use while developing our system. That's all from me. Thank you.
My name is Lee JC, so now I will continue for the demo part. Before go through the code, I would like to show our product first. After we run the code, the user interface is prompted up, and we can see here are several buttons available. For the load image button, is the button to allow user to upload a fingerprint image. So now I will upload two fingerprint image to let the system compare whether it is matched or not. After I click the match fingerprint, the system can show us the result, which is no match, because our threshold is set to 0.8 and this match score is only 0.65. Therefore, the result will be not matched. Other than that, we also have prompt out the image processing pipeline. And the first image is the original image. If this image is not in grayscale, then I will convert it to the grayscale image first. After that, we apply the contrast enhancement so we can see the contrast of the fingerprint is improved compared to the grayscale image. After that, we use the median filter to remove the salt and pepper noise. So we can see here got the salt and pepper noise, and here for the salt and pepper noise is removed. After that, we binarize the image so it becomes black and white. After binarize, we do the morphology so the imperfect will be removed. After done all of this, we thin the image so it will become the image that have a black color background with the line like this. This is pretty much the same things as I said just now. This is the processing pipeline for the first figure. After that, the minutia also have prompt up. So the red color dot is the bifurcation, and for the green color dot is the rich ending. I will try for the match situation. So as usual, we upload two images. For these two images, their match score is 0.83, which already above the threshold, so the result will be matched. Now I will go to the coding. So now I would like to share the core code first. For this function is the function to handle the image processing. So the input will be the raw fingerprint image and the output will be the thinned image. First of all, if the input image is not in grayscale, then we need to convert it to grayscale first. Next, we apply the histogram equalization to improve the contrast of the image. Next, we use the median filtering to remove the salt and pepper noise. After that, we do adaptive threshold binarization to binarize the image. Then, we do the morphological processing, which our structuring element is using the disk shape, and then we do the closing, and we bridge the disjoint ridge, and then we remove the small noise with fewer than 30 pixels. After done all of that, we will thin the image so it will become the image like this one. Next, for extract minutia, this is the function to handle the extract minutia. The input will be the thinned image, which is the output from the processed fingerprint, and then the output will be the minutia map. So after we done this code, it will extract the minutia and label it as red for bifurcation and green for rich ending. Next is the compare minutia. From the minutia we extract just now, it will call to here to compare. So it is a distance-based matching, which is using the Euclidean distance, and the threshold is 15. And then the threshold for match or not match is 0.8. So as I showed just now, if the score is less than 0.8, the result will display as not match. After we done all of this, actually is no output, nothing will display. So we will have some display function to display what we have done just now. For this display pipeline function, we used to display the image processing pipeline, which is this one. And display minutia comparison is used to display this figure. So we can see the minutia extract by the system, labeled by the red and green color, same as the second image. Display match result at this part. So after we match the fingerprint, it will show the match score and also the result whether match or not match. Last, for the main fingerprint recognition is the main function to call all of these sub-function. So before run, we should start at this page so it will not occur the error. For this function, it is used to load the image. This is the available file, available image format for the user to upload. And this is the function to match the fingerprint. That's all from me. Thank you.